Welcome to lecture number 2. So last week has been a quick walk through and an attempt to motivate you for the topic, even though it was slightly depressing. And today we're going to start looking into two of the challenges in slightly more detail, and also going through various definitions so that we start speaking the same language when we, for example, talk about sustainability. And then next week, where I won't be there, unfortunately, because I'm forced to attend the conference in Berlin at the same time, Anand will take over, we'll then talk about definitions of or related to climate change. So today, 2 challenges, next week, 1 challenge. And today we'll also have a more interactive exercise during the Q&A session. For the people online, you can also participate. For the people here in the live audience, you can participate. Who doesn't want to participate can leave and just submit an empty piece of paper. For everyone who would like to play some live games, please stay. And that's it. Let's get started with some content. Let's hope that my pointer works. And it works, great. Good, sustainability. How do you define sustainability? What's the first thing that comes to your mind? Should I start pointing fingers, or can we manage this like grown-up people? You got really lucky. Yes, please. You can also try in German, because I have to repeat for the microphone anyway. Reuse of existing product services. 1 part, good. Next. Not using more than Earth provides us. Yeah. Slightly different definition, but we'll get back to that. Using what Earth provides. Using products that require as little resources as possible and last as long as possible. Okay. Any further additions? Recycling being 1 part of sustainability. Okay. All of that definitely not wrong. And we could spend a whole lecture just going through different definitions of sustainability, some of them being half a page long, others being just a few words. For the sake of that lecture, I would go to one of the slightly more vague ones that also encompasses a lot of things that you just mentioned. This one is from the UN, or one sub-organ of the UN. Developments that meet the needs of the present without compromising the ability of future generations to meet their own needs. What came from the first row, without putting names online now, used this like broader concepts. Other inputs being more, how do we achieve that? How do we achieve sustainability? Like mechanisms to do so, by using as little resources as possible, by recycling, by making products last very long. So essentially means to achieve sustainability with the goal of having sustainability. But slightly more now, like, what is sustainability actually? You don't have to use that sustainability definitions. I'm also very much happy with other sustainability definitions. But when I ask you in the exam, what is sustainability, I would like to have one definition where you're like, okay, on point, this is what sustainability is. And we'll come back to this particular definitions probably 100 times throughout this lecture series, but it's not the only one. But I like it because it's essentially 1 sentence and comprises a lot of the important aspects. Even though sustainability now, being one of the hot topics, it's not actually really a new topic. The origin started somewhere in the 1730s, where a German guy called Hans Carl von Carlowitz thought about sustainability in the context of forest management. because back then, like, mining started to pick up. You need a lot of wood to burn, to melt different types of irons. They did it before, but this is like at the beginning of the Industrial Revolution. It's a precursor to the Industrial Revolution, so it somehow went through the roof. And the British people started lodging the whole forests on their island to build ships, so there was a steep increase in the use of wood. And so people who thought slightly beyond the horizon, like Karlowitz, were like, okay, it takes X amount of days, years, weeks to produce a tree. If we cut down more trees, then we regrow, then there won't be a forest anymore and we run out of materials. So his task essentially in this forest administration was to make sure that there are enough trees. And this is where you can trace back these first origins of thinking about sustainability in the modern sense that we're using right now. Of course, indigenous people have had a similar concept of this, just taking from nature what you need to survive, not stockpiling shit. Like, there have been implicit mentionings of this, but this is more like the original resource consumption focused sustainability origin that we at least are aware of, or which is most prominently featured. So his focus being on this continuously enduring and sustainable use. So I want to use it as much as possible, but not beyond the point where the forest dies, because once it's gone, it's really difficult to grow it back. As you can see outdoors, just outside this window. Good. You can even go slightly further back, another 50 years, where a guy called John Evelyn thought about it in a very similar terms. Sowing and planting of trees had to be regarded as a national duty of every landowner in order to stop the destructive over-exploitation of natural resources. So similar approach, just different countries. They didn't have TikTok or social media. There wasn't such a simple way of exchanging these types of information, especially between two nutheads with very specific, let's call them hobbies or tasks. So it's not like they met on a daily basis. So putting this a little bit in perspective, so Carl coined that term, at least for the Europeans on the mainland, at a time when Europe was in need of vast quantities of wood. So I already gave you the example of mining, smelting, shipbuilding, and so on. So there was a very much a fear of timber scarcity. They also partially applied this to other natural resources, but mostly to timber because that was the pressing scarce resource of that time. And that problem started to compound and get worse because the population also heavily grew. In the 1700s, we had something like 0.6 billion people, which is not much compared to what we have now. 100 years later, we almost doubled. And another 200 years later, we're somewhere between 8 and 9 billion. So double, 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 double. And that, of course, makes the scarcity problem a more pressing issue. And we now also managed to extend that problem not only to a lack of timber, which we at some point figured out is also important for CO2 capturing, but also to various other types. So there are various resources that are nowadays scarce. Also some resources that you would not consider scarce, like sand that you need to build buildings. Type of sand that you need to make cement and as a foundation for buildings. Like you would say there's sand everywhere, but the type of sand that you need for that is quite scarce. And then there are governments who have great ideas like building straight lines through the desert and using millions, trillions, I don't know how much tons of cement just to build a weird project in the middle of the desert where they need to import all the sand because the desert sand is not usable for that from other places and thereby increasing that scarcity. But this is just like being one stupid example here. So during the Industrial Revolution, the environmental degradation increased heavily and the society chose prosperity rather than sustainability. So they had this concept and they knew we can't do this forever, but this is not my problem. This is someone else's problem or a future generation's problem. And this is also something we'll get back to in the exercise. So this idea of meeting your needs now while making sure that the future generations can also meet their needs somehow got kicked off the bridge in this beginning of the Industrial Revolution and remained this way until today. Next definition, biocapacity. We briefly touched that last week when we talked about the Earth overshoot days. And it is the locally available carrying capacity of the ecosystem for generating resources and absorbing waste. So how many resources regrow can be extracted from the environment without causing collapse? So how much wood can I take out of a forest without harming the forest? How much fish can I fish every year? How much waste, because this is the other part of the biocapacity, how much waste can I dump into the environment without destroying the environment? There is a certain capacity to break down different types of waste, of course not all of them, and work with them without causing a direct collapse. But of course, all types of waste that you put into the system are somehow bad. There are a few exceptions like feces, because they're very good fertilizers. But once you put too many on a field, the field dies. So there's always a balance. So biocapacity, in very simple terms, how much can I take out of an ecosystem without making it collapse? And how much waste or burden can I put onto an ecosystem without making it collapse? Pretty simple. Closely related is the ecological footprint, because once you know how much you can take out of an environment and how much you can stress an environment, you can essentially divide that resource budget and that waste budget through the amount of people that you have, and then say, okay, everyone can use 1 block of timber per year and can cause 50 kilograms of waste per year. And the actual damage that you do, the actual resource consumption that you occur or that you cause, is then your footprint. So you have a theoretical limit given by the biocapacity, and then you have your actual footprint on the planet that you leave. So the most famous example here is this carbon footprint. Whenever you book a flight or go on a cruise ship, you usually have, when you book the tickets, this opportunity to set off your carbon footprint. So it takes, 2 tons of CO2 equivalents to go from here to New York. And if you just plant 1 tree, which is ridiculous, that will all go away. So you can calculate your footprint in very different units, the most popular one being this carbon footprint that you try to find for every impact that you have on the environment, an equivalent in emitted CO2s, tons, kilograms, whatever. So let's say you take 1 kilogram of timber from a forest, you can somehow convert that roughly into how much CO2 equivalents would that be. You can do that also in other units, which often make more sense, but CO2 somehow being the most common use case here. So the ecological footprint for a particular population is defined as the total area of productive land and water ecosystems require to produce sufficient resources and assimilate waste. And a lot of countries use way more than they are supposed to do, especially highly technologized countries or countries with an extremely high energy footprint, like Dubai, Qatar, but of course also United States and as well as Germany. And other countries, especially less developed countries, use radically less, and we're essentially borrowing from them, but still exceeding what we should do, as we have seen last week with these Earth overshoot graphs that I showed you, that we essentially live 5 months a year on a credit that we never will pay back. So all obviously related to sustainability when we come back to this definition of only like meeting your own needs without compromising the previous needs. And a slogan that I'll also come back 100 times in this lecture is that the most sustainable thing that you can do in the first place is to consume less or consume as little as possible. Because when you take as little as possible from the environment, you put as little stress as possible on the environment in terms of waste, because all the other steps that you try to prevent this or make good for this are usually connected to a much higher footprint than you would have without consuming it. So You can recycle everything, but recycling is a very energy-intensive process. Recycling takes a lot of manual labor. Recycling in itself causes a footprint. So what's better than recycling is not to need to recycle something in the first place. What's better to not have to repair something is not needing to repair something in the first place, and so on and so on. You get the idea. So the less you consume, the more sustainable the behavior is. Of course, that's not always possible, but that's essentially the gist. So meeting your needs without compromising needs of the others is a heavily resource-focused problem. And we've seen this one last lecture, don't have to get back there, but essentially the gist being here, resources, especially scarce resources, and the more scarce they become, cause conflicts. Conflicts can be just, hey, I want that glass of water, or hey, I want to drill this oil. And something like that happens in the Arctic Ocean, that we try to, or like a more better example probably might be China and Taiwan and all the other South Asian nations who fight over fishing rights. It's very difficult to police any fishing in the vast ocean because it's just so big. And if I just go there fishing without me having the rights to go fishing there, no one will notice. Or what do you want to do? Call the police in the middle of the ocean? Which police? Who's going to stop me? But more precious resources that are not in places where you cannot enforce it, always having this potential for conflict. And you can talk about like super simple resources like water, food, oil, something that runs the world now, but you can also go into more high-tech things like raw materials for the high-tech sector to make chips, to do all this nice tech stuff here. And none of them is infinite. We're living in a finite planet. We're just having this small sandbox of resources, and they're unevenly distributed. So whoever has access to those resources can do whatever they like, and other people might like to have it. And as I said, some of these conflicts might be very shallow, others just ending up in war, has many, many times before, will happen again. So resource wars not necessarily means armed conflicts. Wars can also mean just a fight over resources. But mostly they are violent conflicts that are largely driven by competition for control over vital or valuable natural materials, such as oil, water, land, timber, animals, gold, silver, gems, and other key minerals. So Iraq wars being one good example, Ukraine being, or has been, the largest export of grains in Europe. And in German, you often say they're the Kornkammer of Europe. Right now, quite limited. But even like during the Second World War, there was a good reason to invade Ukraine because there's a vast supply of food. So it's like there's a nice history of this. If you go maybe to Africa, there are various examples where different countries share one large river, like the Nile or others. And it's usually not the case that just one country has access to that whole river. Like Israel and its neighbors is also a good example with the Jordan, that the people who are higher up in the river can use up all the water so that the countries closer to the sea, like being essentially the people who have to use whatever you leave them left, or like what's left after you're done using it, will always be in a bad position. And there have been various examples. For example, I think it was Ethiopia who built a big dam. People got pissed that they kept all the water, and then there was an armed conflict. So sometimes it's like very applicable in a very simple way that you're just running out of water because someone either pulled the plug or made sure that no water is passing. And you have the same setup in China, Pakistan, and India, where they also have to share big streams over country borders. As we said, Iraq war, oil wars, water being the next precious resource, because it's not just easy to control it in terms of managing rivers, building dams, and then deciding how much water you're going to let go. but it's also very much unevenly distributed, and in various regions of the world, it's also very seasonal. So if you think about countries where you have a dry seasons and then a wet season, if the dry wet seasons get out of balance and suddenly you have only dry seasons, then something that you consider a everyday luxurious good that you can rely on becomes something that somehow decides whether you're going to die in the next 2 weeks or not. And as we'll talk about it next week, climate change makes this, or heavily scrambles this schedule or this reliability of simple water supply and makes it way more difficult, because we'll have, as you've seen in Spain last week, sudden bursts of extreme rain events. And at the same time, you will have prolonged droughts. So when I remember the numbers correctly, the amount of rainwater that fell in Valencia was something like 500 liters per square meter in just one day, which was the whole amount, or more than the whole amount, of a normal year there. At the same time, you could now have a season of 12 months without rain. And sure, there was too much water at one point, but now there's too little water for a prolonged time that causes problems. So that makes this war, or this competition for those scarce resources, even more a problem. You can build dams, as I already said, and then risk having a fight with your neighbors. But on the other hand, you also need to build dams, because how are you going to catch those 500 liters per square meter? First of all, to make sure that they don't destroy your cities. But on the other hand, to then have a good resource pool for the upcoming drought. And you can do that for all kinds of resources that are naturally recurring. Next, environmental pollution. What's the definition of environmental pollution? We talked about it intuitively, like stuff that you throw in the environment. So stuff that we throw in the environment that cannot be absorbed, and what do you do with the pollution that can be absorbed? If you relieve yourself in the forest, it's not pollution. Okay? Alternative opinions? Do you all agree with him? Are you now discussing whether you agree with yourself? Yep. So essentially, if everyone starts relieving themselves in the same spot, then we have a biocapacity problem, yes? There was one raised hand. So differentiating between the types of pollution, chemicals being one category. Was there 1/3 raised arm, or was it just yoga? Okay, it was yoga. Okay. Okay, so not just absorbable stuff, but also or things where we have an abundance, yeah? Additions? Let's hope that yeah, good. I was slightly worried that the definition is not on the next slide. Good. Pollution, also called environmental pollution, is the addition of any substance, being it solid, liquid, or gas, or any form of energy, such as heat, sound, or radioactivity, to the environment at a rate faster than it can be dispersed, diluted, decomposed, recycled, or stored in some harmless form. The major kinds of pollution usually classified by environment are air pollution, water pollution, and land pollution. So intuitively, you already got to various aspects of this. So how much can the biocapacity, like what's the biocapacity here? How much is the carrying capacity for a certain substance, like human urine? Also different types, like chemicals. Energy didn't make it to your list, but it's also somehow a little bit of a mean part, because you don't think about it that often, but once you have something like radioactivity, it becomes more intuitive. But there's, of course, also something like sound pollution. Like I'm living in the middle of Braunschweig at an extremely busy street. Sleeping with an open window in the summer is not an option because it's just so loud, even in the middle of the night. And that is sound pollution. Cannot be dispersed, diluted, decomposed, especially not recycled or stored in some harmless form. And this harmless form part is probably the most important aspect here. So you can put a lot of stuff in the environment, but if it's too much or the wrong type of stuff that you put in the environment so that it's not harmless anymore, then we're talking about pollution here. Just as a very much like a simplification of that definition. And of course, once again, there are many definitions of pollution. Very happy to be presented alternative definitions that get like the same information transported, but I find this one very good. Different types of pollution. So last week, I already talked about that example from Greenland, where the truck was just reversing and then dumping the trash into the fjord. We also talked about exporting our waste to other countries and then essentially just leaving it there to pollute someone else's backyard. And we also talked about our green German agenda, while at the same time having 7 of the 10 dirtiest coal plants in Europe. And I think that example is what I left out last week because for time reasons, but also because it fits very well here in this definition of environmental pollution, where it's one form of energy that we try to dispose of. We have been, or let's start the other way around. There's a very heavy debate on whether nuclear energy is supposed to be considered green and useful and something that is supposed to help us stop climate change. Because if you just look at the energy itself, it doesn't emit any greenhouse gases. We'll get back to that next week. Of course, the process of setting up a nuclear plant, of operating a nuclear plant, and so on, there are like still greenhouse gas emissions involved, but just having a nuclear reactor do its things doesn't emit any CO2. On the other hand, that's really just the greenhouse gas emission perspective, and also just on the operation itself, like looking at that reactor. As I said, like you have to build a reactor, you have to get rid of a reactor, you have to operate it, you have to mine that uranium, blah, 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 blah. So you're still causing emissions. That's usually what is like just somehow hidden. But in terms of energy per CO2 equivalent in tons, it's quite good. What is rarely considered here is this problem of what do we do with that waste. There are various ideas around using discarded nuclear material from big reactors and using them in other smaller reactors or new types of reactors. And the idea being that what comes out of them is no harmful at all. Mostly theory that really absolutely less stuff comes out of them at the end, because the more you use it, the less energy it provides, and you don't use it because it's not economical until they are really completely harmless, and it also takes very, 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 very long. So we have to somehow figure out where to put all our radioactive stuff. And since we're using radioactivity in nuclear material for quite a while, a lot of that trash accumulated. And many, many years ago, we had this great idea of let's just put it in barrels. And you know what we do with those barrels? We dump them in the ocean. And we also forget to ask, are those barrels seawater resistant? Are they saltwater resistant? No, they are not. Did someone note where we put them? No, we didn't. We did sometimes, but we have various oceans full of nuclear waste where we don't know where exactly it is. And the only thing we know is that it's in barrels that are now leaking. Great. We also lost a few nuclear bombs, for example, one over Greenland. They're also now somewhere in the ocean, but this is like a minor problem compared to what we did there. And why are they doing this? Why did they do this? Because we didn't really have a safe place where to put them. And in fact, we still don't have a single facility on this whole planet where we can store nuclear material, radioactive material forever. Because it's just super hard and super expensive to do that. We had 2 places in Germany, where they argued, thought, hoped that they would be safe, but both turned out to be not suitable. And now they're, for example, leaking water. One of them, once again, being very close to us, the famous ETCE, where they had an old underground salt mining operation. And they dumped a lot of, I think, low to medium graded nuclear material. They dumped it in there, and then they noticed, shit, water is coming in. And now we're not only having barrels full of nuclear material down there, but also a nice mix of water with nuclear material down there. There is a law in Germany that tries to enforce that by 2030, we have finally selected a location where we can store it, but then we still have to build it. And as you might imagine, there is a lot of political backlash from almost everyone when it comes to picking that location, because you don't want to be the politician that tells the people who vote for you, we're going to put it in your backyard and it's going to be safe. It's not going to happen again what we did in the past. I promise. I really, really promise. So you don't want to be that guy. So whenever they find the location, there's obviously a strong, how do you say that in English? A strong, essentially people who live there are like, hell no. And then also the politicians are like, hell no, we don't do this. So whenever there's a proper location, people try to push back. On one hand, of course, like, totally understand this, and often also for good reasons, because it's quite unclear if those locations are really that suitable, blah, blah, blah. But long story short, we don't have a final location for this. So right now we're just stockpiling it. And the same is true in the US and other countries. There is no final location, at least when I last checked 2 months ago, where we can store that stuff. So until that point, we're just storing it in temporary locations that are not meant to do that, and still having like these ideas of just dumping it somewhere. When we had the problem with the nuclear reactor in Japan, and we had this partial meltdown, they used a lot of water to cool it. They put that water in tanks. At some point, they ran out of tanks, so they came up with very interesting calculations that said, yeah, it's fine, we can dump it in the ocean. We put it in tanks before because we didn't want to dump it in the ocean, but now it's fine. So same line of reasoning there. And of course, it disperses, it dilutes, but in a harmless way. Sure, there is a lot of ocean, but we cannot just dump nuclear energy and nuclear waste into the ocean for all times. So, guessing game for you. We have roughly used now nuclear energy for 2 generations. So first nuclear bomb by the end of the Second World War. Then we figured out how to use it to make energy. So roughly 70 years, 2 generations now. And was quite helpful because it made energy cheap. But how many generations need to manage the leftovers, the waste? So 2 generations profited. How many generations need to manage that waste? Good answer. Depending on how all of this works out, there might not be many generations left, but can I get a number, please? That also then tells me how much or how much time you give humanity to survive. Also interesting question. Oh, you're very optimistic. Okay, 10,000 generations. 1 million generations, okay? Generations. So 10, 100, 1 million, okay? More guesses? At least some of you are in the right ballpark. I'm not saying who. Could be, but for other reasons. So there was one guess that says in 2-3 generations we don't have to worry about that anymore, but for probably other reasons. Good. Correct answer is 40,000 generations have to live with the waste that 2 generations produced. Once again, difficult to get a connection here between the sustainability definitions covering our needs without compromising the needs of future generations. If you have 2 generations who had a really nice life and didn't pay too much for energy, and then 40,000 generations have to somehow look after that waste that we left them. And I would include us there as well, even though we are probably the 3rd generation who profits now, but you get that point. Good, next part, plastic. Plastic being our most beloved product of all time that we made from dead dinosaurs. And we try to recycle a lot of plastic. We'll get to that in a second. But an extremely large amount of plastic just goes straight to the environment. And storing that in a harmless way by diluting it, dispersing that, is more or less impossible. Because plastic very badly degrades. It just gets smaller and smaller and smaller until you have something that's called microplastic, or even smaller pieces called nanoplastic. And you can even find them in your body, in all your private parts, and even in your brain. We're consuming about 2,000 tiny pieces of plastic every week, which you can also visualize by saying this is a credit card that you have to eat every week, or 250 grams a year. No one would do that on purpose. Still, we're doing it. And it's not like plastic production goes down. And there's also, of course, a delayed effect. Like, even if we stop producing plastic now, all the stuff that is already in circulation, slowly getting into the environment, and so on and so on and so on, until we ate all that plastic. It's still going to circulate. And even if we ate all that plastic, at some point we will decompose. So all the nanoplastic and microplastic in us will then be released again until it gets to, I don't know what's below nanoplastic. You get the point. So recycling plastic being one way to tackle that problem, because on one hand, then you need to use less dead dinosaurs to produce new plastic. On the other hand, it also helps to reduce the environmental pollution if you grab all the plastic and then try to make new stuff out of this. I have to admit that figure is slightly outdated. It's from 2016, so the numbers might have slightly changed. I hope for the better, but we couldn't find a good update from a reliable source that we were comfortable using. So from the 78 million tons of plastic produced for this figure, or when this figure was produced in 2016, 98% came from virgin feedstock, which means new plastic made from dead dinosaurs. From the 78 million tons, 32% were just leaked into the environment. We could also just say dumped. Another 40% were put on landfills, so also dumped in the environment. Then we had 14% being incinerated for energy recovery. So another 40% pollution for the environment. And then the remaining 40% have been collected for recycling. We had another 4% process loss, so another 4% pollution. And only 2% made it into closed loop recycling, essentially meaning that you can use the plastic that you used for a water, or that you got from a water bottle, to make another water bottle, because usually there is a quality degradation when you recycle plastic, depending on what type of plastic you use, but usually you cannot use a water bottle to produce a new water bottle. You have to use that plastic to make a less quality product. And 8% went into this cascaded recycling, which is essentially what I just described. I take plastic of high quality and make a low quality product out of it, and only 2% made it into this closed loop recycling, which then means we still need 98% virgin feedstock. Numbers might have changed. The problem, or my biggest problem in this figure, is this part, because 32, 40, and then 14, 86% of plastic is just environmental pollution. And this explains also why you have to eat 250 grams of plastic a year. So in 2050, there will be more plastic than fish in the ocean, not just because we're producing and dumping more plastic in the ocean, but also we're overfishing the ocean. So the fish really have a bad position here, because they're being attacked from different positions. And using plastic and plastic recycling just as one example. I mean, you already got some idea what is challenging about recycling in general, but the plastic here is an example. For example, that when you recycle something, you often end up with lower quality material. Not always the case, but often the case. You also have process losses that we described here. A lot of stuff is just leaked and not even collected for recycling. Sometimes it makes economically more sense to just burn it for energy creation. That being some disadvantages of just relying on recycling. Then recycling itself often requires a lot of energy. glass and various metals are more or less indefinitely recyclable, but you have to melt them. Melting that stuff is a highly energy-intensive process. So yes, you can recycle it, but it still causes a lot of pollution to do so. The pollution might be less than extracting virgin iron or whatever from a mountain. That might still be true, but it still causes a lot of pollution. So not consuming that thing in the first place that causes, or that creates a need for recycling is obviously more sustainable. Some materials cannot be recycled at all, at least yet. Famous example being all the windmills that are put up. This is changing because people notice there is a need for that to build them out of materials that can be easily recyclable. But it's quite challenging, meaning not all parts can be recycled, or they can only be recycled into resources that are barely usable. But there are various examples here. Impurities are another problem. So if you want to get out or get back all the resources from my smartphone, you have to shred it. And since there are a lot of very different resources in here that are only present in very small amounts, means you need to grind it very small so that you have pure pieces, because you are not interested in a piece that is half gold, half copper, just to give a stupid example. You want pure, so you have to make it very small. If you don't make it small enough, then it's impure. If you make it very small, then it's more difficult to separate it. This is like one of the projects that we're researching in one of our research projects. And it also gets more and more energy intensive to do so. It also requires a lot of manual labor. If you just look into your own trash bins, being it yellow, black, or bio-waste, or even the blue trash bin, you will notice that despite quite simple rules, a lot of your fellow citizens seem to struggle with this simple separation concept. Like paper comes in the paper trash bin. No plastic comes in the bio-waste trash bin. Still, in our trash bin, there's always a lot of plastic in there. And those impurity challenges essentially cascade through the system. The people in the initial sorting mess up because they are lazy, or that it's just very difficult to separate different parts. And we talked about the lower quality part, and the most problematic aspect from my perspective about recycling is that it gives you a false sense of safety and hope, because I can recycle it. So it's totally fine if I consume it and use it. But recycling has all of these very unfortunate side effects that we just discussed. And this list is by no means complete. This is just the short list of very intuitive problems that are simple and very easy to explain. That doesn't mean that I'm telling you that you should stop recycling or that you shouldn't start recycling in the first place. But because if you have to consume something that is somehow recyclable, then of course, please recycle it. If you need paper, if you need food that is somehow packaged, then of course, please recycle it and don't throw it in the river. It's just a super difficult and challenging process that can cause more harm than good. Buying less is usually more effective. Good. And that, in this very short lecture, already leads us to our conclusion, and that leaves us a little bit more time for our interactive exercise session. So what did we learn today? Basic concepts and definitions of, for example, what's sustainability, what's biocapacity, what's ecological footprint, what's environmental pollution. And we also looked into various examples for those different categories and also talked a little bit about the limits to recycling. Some additional resources. And now we're going to make the cut where we have the Q&A session where we can ask questions, and then we also do the exercise part. And next week, as already teasered, Anand is going to take over the challenge of climate change. And we might also have a practical exercise at the end. I'm not sure. We'll let you know via the usual communication channels. Thank you very much. We'll make a 10 minutes break and be back at 2:15. No recording, just live session, questions and answers, and today's exercise. Thank you very much.